Good morning. Today we'll discuss few numerical problems on three-phase AC circuits. In the last lecture also we have seen three-phase star and delta connections, and we have determined the line currents and phase currents and also line voltage and phase voltage along with active power and reactive power consumed by three-phase loads. And today we will extend that lecture and we will try to solve few more problems on three-phase star and delta connected loads. So I hope that you will improve in calculation of line and phase quantities of three-phase star connected and delta connected AC networks. So this is the problem. A three-phase balanced system with a supply voltage of 230 volts 50 Hz is connected to a load consisting of R is equal to 25 ohms in series with L is equal to 100 millihenry and C is equal to 496 microfarads. Using the relations between line and phase quantities, determine the line and phase currents when the system is in star and the line and phase currents when the system is in delta. Okay. So it seems that a three-phase balanced system supply voltage is 230 volts 50 Hz and there is an R, L and C. R is 25 ohms, L is 100 millihenry and C is 496 microfarads. These are the values which have been given and you are supposed to determine the line and phase currents. So let's try to solve it now. Now, first of all, let me take that this particular system is star connected. So, before going for star or delta connection, let's just quickly see what is going to happen now. So, when I take these values, now if you carefully see what is there which is present in this problem, you can see that the supply has been given as 230 volts 50 Hz. This is a line voltage and only RMS value will be given for you normally. So this is your line voltage at RMS, this is your frequency and this is your R, this is your L and this is your capacitance, right? So which means that you do have this as your impedance, this is your impedance. Okay, so now you do have a three-phase star connected network and delta connected network. Okay, so whatever might be, this is in each phase you will be having a combination of R and C. Okay, so and you are supposed to determine the line currents and also phase currents. So before going for that, let's note down what are the values which have been given for us. So normally the voltage given will be RMS line to line and it has been given as 230. So RMS line to line voltage is 230 and since it is an RLC circuit, the total impedance is generally given by R plus J omega L minus 1 by omega C. What is omega? Omega is 2 pi F, right? It is 2 into 3.14 into F is given as 50, right? So you will get somewhere around 340. And R value is given as 25 ohms. L value is given as 100 millihenry. And C value is given as 496 microfarad. So you substitute these values in this one to get the impedance per phase. Okay, so when you substitute these values, see, when I substitute R is equal to 25, this is omega, this is L, this is omega, this is C. When I substitute these values, I'll get a final value of 25 plus J 25. Okay, so my impedance, this is impedance per phase. Okay, so now assuming that the load is basically connected in star, so which means that in each phase this is my star connection. In each phase I do have 25 plus J25. Sorry, I think it is 25. Yeah, 25 plus J25. And these are the lines R, Y, B. And since it is a star connection, we know that VL is equal to root 3 V phase. These are in terms of magnitudes only. Magnitudes. And angle point of view, the phase angle of line voltage is 30 degrees ahead of phase voltage. Here, the phase angle of IL is equal to that of phase angle of IPH. Okay. So, this is recording magnitude. VL is equal to root 3 V phase. Okay. And angle of VL is angle of VPH plus 30. Okay. Coming to currents, magnitude of IL is equal to magnitude of phase currents, and the angle of IL is equal to angle of phase currents. So from this, the given magnitude is 230, line voltage magnitude. So I'll consider phase voltage magnitude. So I'm considering only magnitudes. So it is VL by root 3. VL is given as 230 by 1.732. So I'll be getting a value of 132.794. See, this is magnitude only. Okay, so I'll take this one as neutral. So this is my one phase voltage. If you want, this is another phase voltage, this is another phase voltage. Okay, so my phase voltage, what are they? One is VRN, because this is my, right, this is N, this is R, Y, B. So this is one voltage, this is another voltage, this is another voltage. So VRN, VYL, VBL. So what they will be? They will be this 132.79, whatever the value. I'll take this one as 0 reference. So automatically, what will this become? They will become minus 120 and this will become minus 240. There will be a 120 degrees difference between them because the system is a balanced one. Okay, defaultly 120 degrees. If I take this one as reference, the remaining two will be like this. Now, if you want to write the instantaneous values, how to write this one instantaneous value? So this is RMS. When I see, okay, let us suppose this is theta. Okay, this is your equation. Now how to write this is the instantaneous equation. So if I try to write this instantaneous equation now, so what I'll be getting, see 130 is 2.79 into root 2. This is your maximum value, okay. Sine omega value, I have calculated it earlier, it was 314, right? So 314t plus, what is the angle here? 0. So 132.79 into root 2 is 177.7. Into sine, this omega value you can take it as 340. Okay. This is how you need to. So now for this one, what it will be getting? You will be getting same 180. This one is 187.7, 132.79 into root 2 sine 314t. What is angle? Minus 120. So minus 120. For the next one, 314t minus 240. These are the line voltages. Now, sorry, these are the phase voltages. What are they? These are the phase voltages. Now, if you want to go with the line voltages, so how to get the line voltage? Now you do have V phase, VRN, right? What was VRN? It was 132.79. Which was roughly around right. Similarly, what was YAN? Right. So if you want, these are phase voltage, right? Now if you want line voltage in star connection, what you should do, VL is root 3 times of V phase and angle is angle of VPH plus 30. So when I write line to line voltage in star, magnitude must be multiplied by root 3. So 132.79 into root 3, it is 230. At an angle should be added by 30. Similarly, here also into root 3 it is 230 plus 30 means it will become minus 90. Again 230 plus 30 of this one is minus 230. Now if you want to write instantaneous equation, so what you should write here, you will get 230 into root 2, right? 230 into root 2 sine 314t plus 30. Whatever the value which you get here, that you here 230 into root 2 sine 314t minus 90, like that. These are the line voltages. Okay, so these are the line voltages. Now the next one is currents. Now we have got phase voltage and also line voltage. Now let's get back to the currents. Currents, first you should calculate I phase, which is nothing but my PV phase by Z phase. You know V phase, right? It was, I'll take the basic one, 132.79 at an angle of 0 by what was Z phase? 25 plus J25. You convert this one into polar, you will get 56.56, I think. Sorry, no. I think it is 35.35. Okay. So whatever the value which you will be getting, that is your phase current. Okay. See what they have got? 3.756 at an angle of minus 45 degrees. Okay. So what was the phase current? 3.535 at an angle of minus 45 degrees. This was the phase current, right? Which means that I will take this one as R. Sorry, it was 756. Okay. 756. So Y automatically what happens? It will be displaced by 120. Okay. So if it is minus 120, what you will be getting? 1 minute. I think it was. Yeah. 1 minute. I think there is a mistake here. It was 45 actually. This is 45. 45, this is 45, and 120, this is 165. And this is 285. Okay. 45, this is 165, and this is 80. 280. Okay. So now, this is understood. There is a 120 degrees phase shift between each of these phase currents. Now in star connection, you can see line currents. Line currents are very equal to that of phase currents, right? So you can directly take them as, this itself is a line currents. You can take the same values of the line currents. So here also a small mistake. This is 45, this is 165, this is 285. Okay. These are the line currents. So this is how you do it in star connection. Now, when you go to the delta connection, okay, this is, we have already done these things, right? Phase voltage and also line voltage. Now, when you go back to delta connection, in delta connection, what is the values? VL is equal to V phase in magnitude. Angle, both same. But whereas for the currents, magnitude is root 3 times of I phase. Whereas angle is angle of I phase not plus 30, it is minus 30 here. Try to remember this one, the difference. Okay, so I will start with phase voltage. We do already have it. V phase is equal to line voltage, which is equal to 230 in this case. So I'll directly take this as 230. When I do have this, so what is my in delta connection, right? Whatever the line voltage Ry, it is the same as phase voltage, right? So Vry, Vyb and Vbr. These are both line voltage and also phase voltage. So what I'll be getting? This is 230 at an angle of 0. This is 230 at an angle of minus 120. This is 230 at an angle of minus 240. If you want to write it as instantaneous, what you will write? 230 into root 2 sine omega t plus 0. This is 230 into root 2 sine omega t minus 120. This is 230 into root 2 sine omega t minus 240. This is the voltages. Both line and also phase voltage both are same in this case. Now, if you want to calculate the current, then what is I phase? What was I phase? It was basic one was 230 by 0 by 25 plus J25. So what I will be getting? 230 at an angle of 0 by 35.35 at an angle of 45. So I will be getting 6.506 at an angle of minus 45. This is my current. Okay. So in that case, sorry, again there was a small mistake here. Okay. So what was the phase current? 6.506 at an angle of minus 45. This will be IRY. This will be IYB will be, magnitude will be the same, but angle will be separated by 120. Okay. But when you write this equations, instantaneous equations, this will be multiplied by root. These are the phase currents. Next comes the line currents. Coming to line currents, you know that magnitude is root 3 times of I phase, whereas angle is whatever the angle you have for I phase, that will be subtracted by minus degrees, right? So if this is your phase currents, now the line current, what they will become? See, this should be multiplied by root 3. This should be multiplied by root 3. So I'll be getting somewhere around, I think, let me do the calculation. It is 11.26. It's an angle of, see, for this angle again I should subtract minus 30. So this is my IR. IY from here minus 120, so it will be minus 195. IB, it is again minus 350. So these are the line currents. If you want to write the instantaneous equations, then you can go with multiplying this one with root 2. So if I want to write, so what I will get? 11.26 into root 2 sine of 314t minus 75 degrees. Similarly, I can write IY and also IB. So this is the way how you are supposed to determine line and phase currents when the system is connected in star and delta. You can observe that for the same supply, if the system is connected in star, you get maximum amount of currents. Okay. So I'll stop this one here and we'll do one more problem in the next video.